the TI. All right, so let me crack open that bad boy. Eventually, you know how it is. Half an hour later, it opens up. It was doing just fine up until today, but then I updated Big Sur, and here we are. So, all these security things taking effect, and now we play the waiting game. Bless you. All right, so calculator's up and running. Finally, I'm going to store my data. So stat edit. Just a brief reminder, again, if you need to clear out data, you go right up to the column heading, hit clear and enter. Or if you have multiple columns of data, which you'll find that is typical in this course, second plus option 4, clear all lists, wipes out everything, gives you a clean slate. All right, gives you a clean slate without resetting your calculator, which you never ever want to do ever again. All right, so hopefully you haven't been doing that in for some time, but you never know. All right, so 22, 24, twice, a couple of 25s. You can put it in as a frequency table if you want, because the 27 occurs a few times, and we have a couple other repeats along the way, but I already kind of went down this road. I just got to make sure I don't go cross-eyed. You'll find as the course goes on that really the only way that you can screw stuff up, assuming that you have even the slightest sense of how to do any of this, would be on the data entry. All right. All right, so that being said, I probably screwed up the data entry, but we'll see in a minute. All right, so I could always double check, but I don't feel like I want to right now, so I'm not gonna. All right, so we'll start off with the unusual values, because that's the thing we learned about most recently. So unusual values would be any value outside the interval of x bar minus 2s, comma x bar plus 2s. All right, it's also any value that has a z-score that's less than a -2 or greater than a +2. The problem with that technique in this situation is the only way to use that would be to find the z-score of each value, which if you're using a spreadsheet or a tabular approach, it might not be too terrible, but it's much easier to just find the mean standard deviation, run some computations, and call it a day. All right. So what we do is, again, stat calc 1. We only have the list in L1, so unless you put it in as a frequency table, clear out frequency list, go right to calculate, get your x bar, make a note of it. The AP folks want you to do that. I suppose I do too, but I'm not as fervently as they do. So 6.340 is what it would round to appropriately. But once you've made a note of that, you don't actually have to type those numbers in again, because we learned yesterday that we would go to vars option 5, grab the symbol for x bar, which is option 2, subtract from it 2 times the standard deviation, so vars option 5 statistics, then option 3 for the SX. It'll run that computation, then we would round that answer, giving us 18.5. It would go to 570. Now, since we're dealing with integers, a rounding error wouldn't make a big deal in this situation. And believe it or not, the AP folks are forgiving when it comes to rounding mistakes if they're not detrimental to the conclusion being drawn. All right, so a computation mistake that doesn't have any bearing on the conclusion often will still get you a 5. All right, so you could be okay there. But I say don't take the chance and use this technique. So second enter to bring up the computation again. Minus becomes a plus, 43.930. All right, and so we're just going through the data set, given the A or nay, asking, does a data point fall in this interval? If not, it's considered to be unusual. All right, so these are, again, the computations for unusual values. Veils? Nah. Values. All right, so I go through my data set. If it's in the 20s or the 30s, it's going to be fine. All right, and in fact, since all the data is actually organized in increasing order, it's very easy to pick out the outliers. So, and this data set's a couple of years old, but if you're football fans, you probably could have picked out who the 44 and 46s were, or 44 and 46s. Not that you need to know it, but who were they? Both quarterbacks, actually.
How do they are?
So Brady's one of them.
Drew Brees?
Drew Brees, yeah. So there we go. Both old timers. So outliers. Now when it comes to outliers, different story altogether. Wait, Drew Brees is 42?
Yeah.
Oh, that might have been Vinatieri then.
Yeah,
I thought it was quarterbacks. Oh, look at that.
No, but
I said corrected.
Brees was only 40.
Wait, is Brady's the 44 then?
Brady's 44 now.
Now, so then
Then it was probably like.
well, 2 years younger. So I wonder. I thought it was those two.
Yeah, because Vinatieri's 48. 46 Vinatieri.
Yeah, so we got Vinatieri. I'm curious who the 44 was. I pulled this data set myself too.
Maybe it was.
Maybe another kicker. Those kicker or punter.
Yeah.
Those punters keep going until they die.
Or like a Josh McCown or something like that.
Oh, journeyman backup. Pass. So anyway, outliers. So unusual values are values that could technically be part of a set. They make sense to be part of the set. You kind of look at them and say, I didn't see that coming, but yeah, I could see how that could happen. The outliers you look at and say, how on earth did that happen? That shouldn't be there. All right, so that's what we're looking for here. But we don't want to always have to do the computations. There's a way on Desmos, but there's also a way on the TI. So what we would do here to find outliers would be, if we're avoiding computation, is we would create a modified box plot. All right, so modified box plot. So that's going to be second y equals. That brings you to stat plot. All right, so second y equals brings up stat plot. Turn the first one on. All right, we generally only live in the first one, at least for the first couple of units, only because it gets complicated and you tend to lose track of what's in what. So hit enter on the first option, turn it on. There's two box plots in here, one with a couple extra points and one without the couple extra points. You want the one with the couple extra points. All right. So you'll see again that alpha lock came on, but if you clear out, well, we definitely want to clear out the frequency, but you'll see that you're kind of locked into that field. And if I hit graph, it says invalid dim. If I do zoom 9, it's locking me out. So when you go in there, oh, let me hit quit first. Second y equals, do all that jazz. It defaults to a frequency list of L2. Make that, so hit alpha to get out of the alpha lock, make that a 1, indicating that each entry in your L1 occurs one time. All right? Even the repeated values, each repetition still only occurs one time. All right? The mark is just indicating how you want the outliers to be represented graphically. All right? So then zoom 9. Zoom 9 brings up a box plot. I got this straight line here because I have some graphs from another class in there, so I can clear that out, but it wasn't really hurting anyone, so I could leave it there too. But you see that there is an outlier. To get the actual value of the outlier, even though I would think it's probably common sense, again, because the data is in increasing order, it's the biggest one out of the whole set. It's probably the 46, but if you want to play it safe, hit trace, hit the right arrow until you lock on to that outlier, and you'll see that there's an outlier for 46. So 44 and 46 are unusual. 46 is an outlier. All right. So, little shortcuts, little ways of streamlining. Yeah, that's fun. Streamlining things. If you want to know on the Desmos calculator, it's not bad. You still have to type in all the data again, but if you want to do the modified box plot just for convenience, as we go through the course, you're like, oh, I know I could do it on a TI, but it's so much easier to do it on Desmos. Just type in box plot, and then wherever your data is. So if I typed it into X1, I would type in X1. It would bring up an option for a modified box plot, and then you could get your outliers that way too. All right, but that's a little bit unnecessary at this point, time-wise. All right, so